In today's Crystal Formulation Classroom, we will discuss how the solubility and permeability affect bioavailability. Bioavailability refers to the rate and extent at which active ingredient enters systemic circulation to reach the site of action. It determines the effectiveness of a drug in reaching the target tissues and producing the desired therapeutic effect. Understanding bioavailability helps design efficient drug delivery systems and determine appropriate dosage levels to achieve therapeutic efficacy. Solubility and permeability are two key factors that significantly influence the bioavailability of a drug. Drugs with poor solubility dissolve slowly, which can limit the amount of drug available for absorption in the gastrointestinal tract. Once a drug is dissolved, it must cross the epithelium to enter the bloodstream. Only dissolved drug molecules can be absorbed. The formulation of the drug can be designed to enhance solubility, such as using salt forms, nanoparticles, or amorphous dispersion to improve dissolution and subsequent absorption. The presence of food can also influence drug solubility by changing the pH and composition of the gastrointestinal fluids. Drugs with high permeability can easily cross cell membranes through passive diffusion or active transport mechanisms, leading to higher drug availability at the site of action. Permeability can vary along different parts of the gastrointestinal tract. The small intestine generally has higher permeability due to its larger surface area and abundant transport proteins compared to the stomach and colon. Efflux transporters such as P-glycoprotein can pump drugs back into the intestinal lumen, reducing their absorption. Improving the bioavailability of drugs with poor solubility and/or permeability often involves formulation strategies, such as using prodrugs, solubilizers, or employing delivery systems like liposomes or nanoparticles, and so on. Thank you for joining us in this episode. Our upcoming session will focus on the analytical techniques for studying solubility.